All right, hey, couple of things, you guys. The end of the quarter is coming up real soon here. I have got all your tests in there now. I would like to go over everybody's grade that wants to go over it with me today. So before you leave today, we're going to do that. And right here, I have an extra credit assignment. Now, you guys remember this? It's real easy. You might have to look some of it up on the internet, because it's things like knowing Roman numerals. Okay, so you might need to look some of it up on the internet. Also, there's words like gross that you need to look up. What is a gross? Okay. Okay. So you're going to do that now. So you guys are going to figure those out. It'd take you about 5 minutes. In fact, my other class had it done before they left today, most of them, not all of them. And the assignment I'm going to give you today, they all had that done. So we should be able to do that. Huh? I'm giving you an extra credit assignment and another assignment. And you should have them both done. Okay? Huh? Yeah, it is. Okay? All right, now. You guys ready?
Yeah.
Now, the last day I'm going to let you turn in late work is Tuesday. Okay?
And when are we going to take
Listen. The last day, everybody, to turn in late work is Tuesday. You might want to write that down if you have late work you're planning on turning in. Okay? Some of you need it so you can pass class. Okay? Or get your grade up for some of you. So make sure we get that in. The last day to turn in late work is Tuesday for this class. Most of your classes probably stop today. I'm going to give you till Tuesday. Okay? Now, if you want an extra credit assignment, raise your hand. All right, for your bell work right here, when rolling 2 dice, what is the probability of rolling a sum that is greater than 7? What do you guys think? 5 out of 12. That's right. Why is it 5 out of 12?
Because of the probability of...
How many total how many desired outcomes were there, you guys? There was 15 out of 36, right? And it reduced to 5/12. There was 15 numbers on that chart that's greater than 7. Remember that? What is the probability of rolling the sum that is odd? Well, it's actually 18 out of 36, which reduces to 1/2. And I know 6 out of 12 is 1/2, but you want to reduce them all the way, right? Okay. It's what? You didn't understand any of these problems? Number 4. Oh, okay. We're getting that one. Number 3. What is the probability of rolling a sum that is greater than 7 and is odd? Well, if it's a sum of 7 and... What is the probability of rolling a sum that is greater than 7 and is odd? Well, what'd you guys get? It was 6 out of 36, which is 1/6. Is that what you guys had? Because the only numbers that are greater than 7 that are odd are which ones? Which numbers? Gabe, focus.
Yeah, sorry. Because Callie doesn't want to stop talking. Tell him to shut up.
Which numbers are greater than 7 but are odd? 9 and 11.
Oh, 9 and 11.
9 and 11. How many 9s were there on the chart? You guys aren't even looking at your charts, are you?
Oh, what charts are we looking at?
Your tables. The one where we had the dice. We had 1 through 6 and 1 through 6, and you filled them in.
Oh yeah, there's like 5 or 6 of them.
Okay.
What's the minimum US 30?
I got 1 9.
Is the event rolling a sum greater than 7 and rolling a sum that is odd independent? You know what? This question doesn't really apply to this, so we'll just forget that one. All right. Okay. Is that the last bell work?
Yeah.
Oh, actually, no.
We have.
We're gonna save that till next week. You guys, this is another thing that's going on this quarter's grade. We're gonna fill this in through next week, and then we'll turn it in. We'll probably turn it in Thursday next week. So we'll only do 9. It will go on this quarter's grade. So especially, if you haven't missed any bell work points, this is not going to help your grade go up, but it will make it go down if you don't turn it in. But if you have missed bell work points and you do well on this and you turn it in, then it'll help your grade go up. So make sure we get it in, especially some of you. Some of you guys haven't even turned in bell work yet. Okay, so make sure you turn them in. All right, we'll get that next time. All right, we're going to correct the assignment right now. I will answer. I think you guys got most of it done, but I'll answer 1 or 2 questions on it if you have it before we go. Go to problem set 3 side first. Which ones do you want to do on problem set 3? Huh? 27 on problem set 3?
Yeah.
Okay. You guys, this is number 27 on the first side.
So
It says,
4, right, on the bell work?
yeah, we're not doing 4 on the bell work.
All right.
Okay, Jim Shue scored 9 points in a basketball game. Long shots count 3 points. Field goals count 2 points, and free throws count 1 point. And he scored 9 points, right? Jim scored 9 points.
Be 3 threes.
It says, number 27 says, make a list of the 12 ways that Jim could have scored 9 points. Okay, well, we could make a table somehow. And how many 2s, how many 3s? Okay, let's see. Well, let's see. Ones, 2s, and 3s, right? We could have gone 1, 2s, and 3s, and it's supposed to add up to 9, right?
Yeah.
Total. So let's do this right here. See, I don't know what the best way to do that is right there. Okay, well, he could have had,
9 free throws.
he could have scored 3 of these, right? This is one way.
Yes.
Okay. He could have scored 3 threes. That would make 9, right?
And then 4 2s and 1 free throw.
He could have scored,
Yeah, this one's weird. Like, how we get to do this one?
no, I'm trying to think of how to do the table the best.
Yeah. You know. That's why I didn't try.
Well, we could just list them. You could score 3 threes, right? Oh, yeah, we could do it that way. That might be a good way to do it. Okay, we could go like this. 1, 1, 1, 1, 1, 1, 1, 1, 1. We could have scored. We're gonna put, yeah. So 9 ones. Let's just put 9 ones. That's faster. Scored 9 ones. We could have scored 3 threes. That's another one. What do you think? What else?
Yeah, but then you can't be like 4 2s, 1 1.
Huh?
4 2s.
4 2s. There's 1 1. Oh, I see what you're saying. Maybe we'll try it that way. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Or 3, 3, and 3. Or 2, 2, 2, 2, and 1. What else? 3, 3, 2, 1, right? 3, 3, 1, 1, 1. 2, 2, 2, and 3. 1, 1, 1, 2, 2, 2 would work.
You can do all free throws.
Okay, 3 and
1 3 and 3 2s. Oh, you already did that too, also.
2, 2, 2, 1, 1, 2. Oh, did I already do that one?
Yeah, it's just you have it backwards the way I have it.
No.
3 1 3. That's it.
No, yeah, you need 1 more free throw.
One more free throw right there.
You already
Oh yeah, we've already got that one right here.
So why can't that be like this?
So we can go 2,
Or like
2, 3, 3. Do we have 2, 2, 3, 3?
Yeah. No.
Oh,
2, 1, 3, 4.
oh, that would be too many. 2, 2. Wait, who's got one that's not up here?
3, 1, 1, 1, 1, 1, 1. Oh, you
All right, we got that one.
You have 2, 2, 1, 1, 3. 2, 2 twos, 1, 2 free throws, and 1 3.
Is that like that? Do we have that one?
Okay, but,
You know, after I want my.
There's probably a way to make a table and get this organized and do it, but
yeah, you're a funny guy.
Yeah, I should be a comedian, you know.
You should.
I'm thinking about it because I don't know where I'm going.
Next, like,
there's 3 more.
2, 1, 1, 1.
You don't need an education to be a
2, 2, 2, 1, 1, 1. We got that one.
stand dropout. Give me a
just
hope.
go stand up there.
How about 1, 3,
Stand up there.
a 2, 2, 2, 2, and 3? Do we have 2, 2, 2, and 3? 2, 2, 2, and 3.
We had that already.
We do?
Yeah.
Where is
straight
that one?
twos.
Oh, yeah. We do have that one. I looked and I didn't see it.
We have them all, don't we?
We have 2, 3, 3, 1.
It says there's 12 of them.
3, 2, 1, 1.
No way, there's 12.
3, 2, 1, 1, 1, 1, 1.
Just have different order.
Do you
That's
have
10.
1, 1, 1, 1, 2?
Do they want us to
Do you have like all ones and 1, 2?
Do we have that one already? 4,
Put 6 ones and 1, 2. Oh, no, 7 ones and 1, 2.
7 ones, and 1, 2? Okay.
And then that's. I'm not immoral.
Hey, we need one more.
Special.
Yeah, I don't know.
What's the one more we're missing?
3, 3, 3, no.
You already have 2 2s and 1.
We have the one with 3 3s. We have a 3 3, a 2 and a 1, a
Oh,
3
no,
3
you're
1
missing
1 1.
one. It's no. You have that one also.
We got all the ones with 2 3s in it, or 3 3s.
You got 3 3s and 2
2
2s.
2s with all ones.
Yeah. Yeah, you don't have
We don't have that one. Is that the one we didn't have?
Except
All
the
right.
base of 1.
Huh? That's right. That adds up to 9. Okay, make a list of the 12 ways that Jim could have scored 9 points.
That's too loud.
There they are.
No, it doesn't.
That's too.
Take off
That's
the
too.
1 on that.
Is that all of them?
2, 4, 6, 7, 8, 9. Wait.
It's 9 we're adding up to, right?
Oh.
Okay,
Oh.
that's it right there. I think we got them all.
Yeah.
Okay, what are there any other questions?
That's
Like-
what I just said. I
but like-
bug bite.
27 on the other side?
No, wait, no. Go back. Go back.
Okay, 27 on the other side says the Zebras scored 30 points in a football game. 27. How many ways could the Zebras have scored 30 points without scoring an extra point?
I just got myself Spider-Man. I was wondering if I'll just
Okay.
Spider-Man.
Wait.
Well, look, I can just change it each level.
Okay, do 26 or 27 on the backside. 26? Well, 26 is list all the ways that they could have scored 30 points, and that includes extra points, right? They could have scored... They could have scored 3 touchdowns with extra points, right? That's 21, and then 3 field goals. And they could have scored 3 touchdowns. They could have scored 4 touchdowns and a safety, right?
Did you count the?
And they could have scored 3 touchdowns,
And that's 7.
a field goal, and 3 safeties. I don't,
Could've scored.
not likely, but could
Let's
have.
go 3 field goals and 1 safety.
Huh?
Wait, how much?
There's
is
way
it?
too many options here. Okay.
This is dumb. It's gonna be the dumbest question.
Hey, just
Dumbest question so
because it gets hard doesn't mean it's
No, I mean, there's
dumb.
Just a list of
It
numbers.
makes you think about adding up numbers.
Well, so our left brain.
Your left brain has
I was also wondering why your head's a little bit smaller on this side, right over here.
That's why I can.
Just kidding, Chance.
It's like a whole thing and then like a little like the fork
Okay.
on one side.
Yeah. Some of you guys' heads are crooked
Yeah.
a little bit. It's
I've
just
been bumped on my head.
not
Don't
yours.
even look
Not
at
not
me right
yours,
now.
Sarah.
Don't look at me.
I have
Okay.
a video of it.
All right. What else? How about
5, 6, no extra points.
that's another option. No extra points. You know what? That's good enough on that one. Okay.
Oh my goodness. Can we go back to the next one?
Pointless.
But you make you organize them. There's a different way to organize it so you could get it.
So then what
So
would
if
make
we just write that, then we're good.
You could have scored 10 field goals.
How much are we trying to find out?
10 field goals.
Oh, I see what you're saying.
Right.
You mean try to make 30 points.
we go back to the last one?
The last one?
Yeah.
That one?
You can make 2 touchdowns.
Okay. Okay, here we go now. You know, when I was in high school, I scored 10 points in a basketball game. They were all free throws. I didn't tell you that. We were playing at Moapa Valley High School. I remember it. My grandma and grandpa were there watching because they had a summer home in Moapa Valley, and I scored 10 points, all from the free throw line.
Are you gonna count these ones that like how many ways could he have scored 9 points without scoring?
As long as you got at least that many.
I know, but that's a different question. There's 2 more after.
Yeah. No, there's only one more after that.
Wrong side. Well, there's
Oh.
different ways that the aardvarks could have scored 21 points.
Well, number 28 is even easier than 27. You guys? 28 on the front side and probability 3. Okay? Help me out again, Gabe.
All
Right here, 28.
How many times Charlie was
No, this one right here on the other side. How many ways could he have scored 9 points without scoring a free throw? This makes it even easier.
Because there's 3, 3, 3, that's one of them. And 3, 2, 2, 2. And then 3, 3, 2. 3.
No, you can't score 2.
Oh, no, wait.
We could have scored 2, 2, 2, and 3.
Yeah, that's what I meant.
Oh, this one doesn't work. 3 field goals. 3 3-point field goals. That's probably it right there.
Cheesy.
I can't think of any other ways. Can you guys think of any other ways?
I think it might be 2, actually.
So that one's easy. See, there's only 2 answers. Number 29. How many ways could he score 9 points without scoring a long shot? Without scoring threes?
Oh, okay, so...
That's just all of these right here, you guys, except for the 2 that we just wrote down, right?
So 6, that's 6.
All the ones without threes. All the ones without threes. So this one, this one, this one, this one, and this one.
It is a
5 of them is all. It's all the ones without threes.
It's not right. You said it's actually 2. Oh, 5? No, it's 6, actually.
The Brain Buster makes all kinds of sense. Right. Look at this. How many rectangles did you guys get? 5, 10?
5 and 6. There's 6,
Someone,
there's 12.
someone in this class came up when I did it with them.
It was 15.
Oh, it was Nicole. Yeah, Nicole did. Nicole had actually 21. She double counted some. But Lindsay, Cal,
6 with 3, so...
there's actually how many?
No, it's 15.
There's 15. Watch. Here we go. You guys, there's each individual square. A square is a rectangle, right? So 1, 2, 3, 4, 5. Okay? There's 5 of them right there, the small ones. 5 of the one. A square is a rectangle. A square. Hey, is a Mustang a Ford? But is a Ford a Mustang?
It's Ford a Mustang?
No. Is a Mustang a Ford? Okay. But are all Fords Mustangs? No. A square is a rectangle, but not all rectangles are squares. but a square is a rectangle by definition. Okay, a square.
So is a rectangle.
The definition of a rectangle is a quadrilateral with 4 right angles, and a square is a quadrilateral with 4 right angles. Okay. All right, here we go. You guys, there's 5 right there. Now you got to count all the ones that are 2 squares. There's 1, 2, 3, 4. 4 2 by that have 2 of those squares. And then you got to count all the ones with 3. 1, I know. 2, 3. That's all of them that had 3 in there, right? So there's 3 of those. And then you got to count all of them that had 4 in there. There's 1 right there and 2 right there, right? So there's 2 of those. And then there's the one big one, right? That makes 15. Okay, you got it? Okay.
Yeah.
Nicole, when she came up to me yesterday, she actually had done all those, but she had just double counted some of those. She saw them all, so just double counted. So. All right, is that it? Are we ready? 29? How many ways could have you scored 9 points without scoring a long shot? We just did that one.
Yeah. Was it?
5.
Okay.
And then the other one.
There's 5 ways, but you got to list them all.
Do the aardvark.
This one's 15, right?
Yeah, that is. Well, you got to pay attention to find out. What? 24 on which side?
The other one.
28.
24. List all the different ways that the Aardvarks could have scored 21 points. The Aardvarks scored 21 points in a football game. 6 points are awarded for a touchdown, 3 points for a field goal, and 1 point for extra point after a touchdown. Oh, they don't say anything about 2 points, right? So we don't have to list all 20 points. Well, they could have scored 3 touchdowns, right? 7, 7, and 7. 3 touchdowns with. They could have scored 3 touchdowns, missed the extra points, and scored a field goal, right? They could have scored, yeah, 1, 2, 3, 4, 5, 6, 7. They could have scored 7 field goals. They could have scored 6, 6, 3, 3, and 3, right? Could they scored just 1 touchdown with an extra point? Well, if we would have scored 1 touchdown. No, you can't just score 1 touchdown with 1 extra point. You're going to have to score extra points every time. That might be it. Oh, you can do. Oh, you can do this one. I think that's it right there. That's all the ways. Okay. All right, let's, yeah. That's number 24 on the problem set 4.
You do the one after that, too.
We already did.
List how many ways the Aardvarks could have scored 21 points without a field goal.
Oh, the Aardvarks could have scored a point without a field goal. You could have got 7, 7, and 7, right? No, you can't go 6, 6, and 6. Because then you'd have to have a field goal.
So it's only 1?
I think that's the only way I can think of.
We could turn this in next.
Okay. No, we're going to turn it in right now. Okay, we're going to correct it. You ready? We're going to correct 5 problems on each side. You guys ready? We're going to do, everybody's go to problem set 3.
My Lord God.
Hey. Guys, everybody pass it. What did we do? Pass it forward or backward yesterday?
Backwards this time.
Guys, today we are going to talk about conditional probability. Right over here I have the objective written down. Everybody write it down. Conditional probability. All right. You guys, what is conditional probability? Well, first thing I want you guys to do is see these? See this notation that we're going to use over here? Probability of B given A is equal to the probability of A and B divided by the probability of A. Okay? Probability of B given A is equal to probability of A and B over probability of A.
Oh, that's right.
Got it? And we can write it the other way. Probability of A given B is equal to the probability of A and B all over the probability of B. Now, you guys, I got to tell you, I have never taught conditional probability before. In fact, I had never even heard about it until I read about it in my new core curriculum.
So they're still coming up with new stuff, like formula?
No, it's been around for a long time. I just never,
You weren't learning it during
I just
during
didn't,
school?
all my other classes that I've ever taught probability in, I haven't taught this, but for some reason now it's in the
Yeah, I
curriculum.
have a question.
Okay?
Has anything changed since you're a kid in high school? Like, you know how you
Well, you guys, this kind of math that we're doing right now has been around for hundreds of years.
Yeah.
Okay? So has math changed? No. The way we teach it changed? Yes.
Oh, okay.
Okay? But math has not changed since I was in high school.
No?
There's math that's changing, but it's the
Learning it more.
it's the upper level math that's changing because they're discovering new math all the time. Which brings up a point. Is math discovered or is math invented?
It's discovered because I don't think it's invented because it's already numbers.
They have to invent formulas.
Well, yeah, but there's inventions
Well,
everywhere.
What did they, maybe a little bit of both. They had to invent the notation for math, right? But if there was 5 eggs when a caveman found eggs, there was 5 eggs. He just had to give it a name, right? And different languages have different names for things, Raiden. So different places have different names for things. So math is discovered more, but the symbolism for it, the notation for it, is invented. Okay? So that's the difference right there. Math is discovered just like in science. They discover why cells do what they do, and things like that. So math is discovered. It's not invented. It already exists. We just have to invent it. We have to give it a name, just like scientists have to invent science. They have to discover science and give it a name and understand it. And so that's all we're doing with math. All right, now today, you guys, I'm gonna show you this picture to help you try to understand it. How many of you guys? I'm going to give you this picture right here. I have 2 blue marbles and 3 red marbles, okay, in a bag, okay? Austin, I have 2 blue marbles, 3 red marbles in a bag. If I have you reach in and grab them, what's the probability that you're going to grab a blue marble?
2 out of 5.
2/5, okay? So we get this right here. We have a 2/5 chance of getting it. And now there's going to be 3 red and 1 blue left, right? Okay, let's go back to this again, you guys. What is the probability, Savannah, that I'm going to choose a red one out of here? Huh? 3/5. Okay? 3/5. There is a 3/5 that I'm going to get a red. And if I do, there's 2 reds left and 2 blues, right? Does everybody understand this? Okay, now, here's the next step to this. I should have drawn this smaller. In fact, maybe I'll make it smaller. Okay, now, guys, let's go back to this right here. What is the chance that once I draw a blue marble out of here, that I can get, that on my second draw, without replacing it, that I'm going to get a blue marble? 1/4, right? There's a 1/4 chance, right? Okay? That I'm going to get it, given that I already got that other one, right? What about down here? Oh, wait. What's the chance that I could get, given that I got a blue marble the first time, what's the chance I could get a blue marble on the next one? No, I mean a red one.
Oh, 3 out of 4?
3 out of 4, right? And if I did that, I would have a blue and 2 red left, right? Do you guys get what we're doing right here? Okay, next one. What is the chance, I should put an arrow right there. If I chose a red one the first time, what's the chance of choosing a blue one the second time? 1/2. It's 2 out of 4, right? What's the chance? And that would give me 1 blue and 2 red left, right? Does everybody see that? What's the chance of choosing a red one here, given I chose a red one the first time? 1/2, because there's 2 out of 4, right? And then there's 1 red and 2 blue left. Raise your hand if you see what's happening right here so far. We're drawing a tree diagram of this. If this happens, then this happens. So these are all the possibilities that could have happened if I would have went 2 draws without replacing. This is what we call dependent probability, okay? One depends on the second pick depends on the first pick. Does everybody kind of get this idea?
Yeah, can you leave it up just for a moment?
Now, I want to know, you guys, what is the total probability of having chosen 2 blue marbles in a row? This top one right here.
Total?
What's the total probability? What's the probability of choosing 2 in a row? Huh? 2/20. Why is it going to be that? You're right. That's right. Did you guys see that? Just like in independent probability, we multiply them together. In dependent probability, we're going to multiply 2/5 times 1/4. We get 1/20, which is 2/20, which is 1/10. There's a 1/10 chance that if you guys had 2 blue marbles and 3 red marbles, that you would pick up 2 blue marbles in a row. Got that? What's the chance of getting a blue on the first draw and a red on the second draw, you guys? How would you do that one? Everybody do it, and then tell your friend what you did. Getting a blue on the first draw and a red on the second one, so you ended up with 1 blue and 2 red inside.
Okay, so you have it together.
But you wanted a blue the first one and a red the second one. Okay? Everybody got it? Because I'm gonna pick on you. Stephanie, what's the probability of doing that? Getting a blue marble the first time and a red marble the second time. Well, getting a red marble the second time. No? Well, you got a blue marble the first time, right? So you followed this one. You went to there, and then you went to here. You multiply them together. What's the probability of getting the first one? What was the probability of getting a blue marble the first time, you guys? There was a 2/5 chance that we got a blue marble the first time. What was the chance of getting a red marble the second time? A 3/4. Add those together, or times those together. 2 times 3 is 6. 20ths, which is 3/10. You had a much higher chance of getting a blue marble the first time and a red marble the second time than you did of getting 2 blue marbles, right? Okay. All right, I'm going to ask another question, then I'm going to pick on you. What's the chance of getting a red marble the first time and a blue marble the second time? A red marble the first time and a blue marble the second time. A red marble the first time and a blue marble the second time. Okay? Chase, what do you think? 3/10. What do you guys think? Is he right or wrong? I said 3/10.
I'm with you on that one.
Well, a red marble the first time is 3/5. A blue marble the second time is 1/2. 3/5 times 1/2 is equal to 3/10. Okay, so 3/10. It's the same as this one right here, isn't it? Okay, last one. I'm going to pick on someone this time. Don't raise your hand. What's the chance of getting a red marble on both draws? A red marble the first time and a red marble the second time. Red marble both times. Ethan, what do you think? Okay, what's the chance of getting a red marble on the first draw? 3 out of 5. Now you got 2 blue and 2 red, right? What's the chance of getting a red marble on that draw? And what do you do with those numbers? Times them together. What's 3/5 times 1/2? And you get 3/10 again, right? Those probabilities should all add up to 100% to 1, do they? Tell me how, Gabe.
It's over 10. Let's say we have 30 or
No, you can look at the numbers right there.
Wait.
Because those 4 probabilities we just came up with should add up to 1. Do they add up to 1? 1/10 plus 3/10 makes what? 4/10 plus 3/10 makes 7/10 plus 3/10 make 10/10, which is 1. Because all the probabilities have to add up to 1. So you have a 100% chance. You have a 100% chance of picking 2 marbles out of here, don't you? Okay? And we just want to know what colors are going to be. And this is the breakdown of what colors are going to be in which order we picked them, right? 1/10, 3/10, 3/10, and 3/10.
So like another way of checking your answer.
Yeah, that's a way to check your answer. Now, this is called dependent probability. However, this is what conditional probability is. Okay? I want you guys to see. I want you to do this. We're gonna call this. I want everybody to write this down. Probability. Okay. No, we're just gonna say event A. A is the event of choosing event of a blue marble on first draw, okay? B is equal to the event of a blue marble on the second draw. Got it? C is the event of a red on the first draw. And D is the event of a red on the second draw. We're going to tie this into the notation that we have. Okay? Now, I'm going to say, okay, the probability of B given A. Everybody Everybody read this with me. Probability of B given A.
Probability of B given A.
One more time. Probability of B given A.
Probability given A.
What does that slash mean right there?
It's the slash for A.
It's given. Now, what does that mean? Probability of B given A.
You have to find B and A to get P.
It means the probability of, what does B stand for, everybody?
Probability. No, B is the even blue second.
A blue on the second draw, right? But it depends on, in other words, this is saying, what's the probability of drawing a blue on the second draw, given that I drew a blue on the first draw, right? So it's going to follow this path right here. What is that probability, you guys?
It's gonna be 1/4.
No. What is it? 1/10. The probability of a blue on the second draw, given that I got a blue on the first draw, follows this path. It's 1/10, right?
Oh, okay.
Okay, you ready for the next one? Probability of A given B. Everybody, when you know it, raise your hand. What's the probability? What does A stand
Wouldn't
for?
it be 3/10
What does A stand for? Getting a blue
first?
on the first draw, right? No.
So that's 2/5.
Oh, wait. We can't really ask it that way in this case. Oh, wait, no.
So what happens to C and D then?
I shouldn't, hold on. I shouldn't ask that way. Let me see. Because red, I can't really do that one. Probability, let's go probability of D given A. Which one of those is it following right there? D given A. What is D? D is the event you're going to get a red on what?
3/10.
The second draw, given that you got
A blue.
an A. What's the event of A? A blue on the first draw, right?
Yeah, wouldn't it be 3/5 1/2?
Well, which one of them? Because all the answers left are 3/10. So which path is it following? Yeah, it's this one right here. It's this path right here, you guys. It's asking, what is the event of getting a D, which is an event of getting a red on the second draw? Here's my red on the second draw, given that I got a blue on my first draw. So it's this path right here, 2/5, 3/4, which is 3/10 right here, right? Okay, I want you guys to tell me this one. Which one is this one? I'm going to do probability of B given C. Probability of B given C. I want you to tell me which path we're following right there, you guys. Probability of B given C. Try this. Come on.
Blue second, event red plus. Yeah.
Probability of B given C.
It's times 1/2 equals 3/10.
Wouldn't it be?
Okay. Which path is it following?
The third one?
The third one, yeah.
When it goes across to one.
Because I want C. C is the probability of getting a red on the first draw, right? I mean, I want the probability of choosing a blue one if I chose a red one first. Here's a blue one if I chose a red one first, so it's the third one down, and that's equal to 3/10, right? The last one, you guys. The last one I haven't done yet, right here. The fourth path. What would I call that one? What's the notation that I would write for that? The probability of C given what? I think it's the other way around. Probability of, I'm getting a red on the second one, right? And a red on the first one. So the probability of the red on the second one is probability of D, right? Probability of D, given that I got a red on the first one, which is of C. Probability of D given C. Got it?
Yeah.
All right. That's what this means.
Yeah.
Now, I'm just going to show you. So let's say I wanted the probability of A and B happening right here, okay? Probability of A and B happening. Well, if I go back to this, you guys, the probability of A and B happening is the probability of A and B both happening would be the probability of this first one right here. It's the top path that we're taking, right? It's the probability of B given A. So I'm going to go down right here. Wait, where was I? I lost my place here. Yeah, probability of A given B is the probability of A times the probability of B given A. Let me show you what I did, because you guys probably a little bit confused on this. Everybody look right here. You guys, this is the probability of A happening, right? So I'm going to write this in a different color. I'm going to write this in black. This is the probability of A right here, 2/5. What is it? It's 2/5, right? And this right here is the probability of B given A right here. The probability of that is 1/4. So P A, so I'm going to times P of A times P of B A. In other words, 2/5 times 1/4, I get 1/10, right? But we write it like this. We write it as probability of A times probability of B given A. This was the 2/5. This was the 1/4, and it was equal to, what was it equal to, you guys? 1/10. This is the 1/10 probability of A and B. Got it?
Yes.
Now, look at these equations that we started with. See this one right here, the top one? What could I do to both sides of that green equation up there on the board to make it look like this one?
You have to.
What would I do to both sides of the equation?
Oh yeah, minus B pi.
I've got to divide both sides by a number. What? Which one? Yeah, P of A. That's what I got to do. I'm going to divide both sides of this by P of A. And if I get it, those cancel out, and I get P of B given A is equal to the probability of A and B over probability of A. That is the notation that we are looking for, you guys.
Why would you use P of A? Is it because they all have P of A? Like
P.
I'm so confused.
Okay. It's all right if you're confused, because you won't be after I teach you this next part. Did I just hand out your assignment to you, or did I not? Oh, I was going to before the... Let me pass them out really quickly. Okay, really quickly, you guys, so you know what you're doing. Everybody turn to the second page that has examples 1, 2, 3 on there. Everybody turn there. Probability examples 1, 2, 3, and 4. There's 5 problems on your homework assignment. It'll take you 5 minutes to do them if you know how to do these examples, and they're really not that hard. Okay, here we go. I want you to see this right here. You guys, the probability of B given A is just the intersection of two probabilities divided by the given number. So, in example 1, a jar contains black and white marbles. 2 marbles are chosen without replacement. The probability of selecting a black marble and then a white marble is 0.34. Notice, you guys, selecting a black and a white. The word "and" means intersection, right? So 0.34 is my intersection. So right here, I'm going to put 0.34 on my intersection. That's the probability of A and B. Don't put your stuff away yet. Okay? No. Okay, the probability of A. The probability of A. It says, and the probability of selecting a black marble on the first draw is 0.47. That's my given probability right here. Okay? All I have to do, and it says now, what is the probability of selecting a white marble on the second draw given that the first marble drawn was black? That would be the probability of B given A, this part right here. Well, all I have to do is divide 0.34 by 0.47. Everybody get out your calculator. Go 0.34 divided by 0.47. What do you get? 0.72. If I change that to a percent, I get 72%. There's my answer right there. Pretty easy, right? Don't worry about that yet. Just go to the examples. Example 2. Okay. I'm showing you right here, Chase. Watch what I'm doing. You're trying to do your own thing right there instead of listen to what I'm saying. Listen to what I'm saying, then you'll get it, okay? I want to know what the probability of B given A is in each one of these cases. They're going to give me the intersection and the given one. So look, you guys, The probability that it is Friday and, everybody underline the word and on that, and that a student is absent is 0.03, which, right here, on these examples, right here. Number 2, we're on example 2. The probability that it is Friday and that a student is absent is 0.03. Notice it says and. See this? An intersection is and. Well, how much is that number? 0.03. So we're going to go 0.03 on the top divided by, since there are 5 school days in a week, the probability that it is Friday is 0.2, right? What is the probability that a student is absent given that today is Friday? That's what I'm looking for. That's going to be 0.15, which is equal to 15%. All you have to do, all you have to do is find out which one says and in it. That's on the top. The given one on the bottom. Divide the top, that one by the given one. Okay, go to example 3. At Kennedy Middle School, the probability that a student takes technology and Spanish. Everybody underline the word and. Technology and Spanish is 0.087. So, since that's an and, it's the top number. Divided by,
What is that called again?
the probability that a student takes technology is 0.68. What does that come out to be when you divide those numbers? 0.13, which is equal to 13%. There's my answer for that one. Got it? Oh, number 1 is easy. In New York State, 40% of all teenagers own a skateboard, and 39% of all teenagers own a skateboard and a rollerblades. Which one said and in it? Skateboard and rollerblades. See that one? What number was and? 39%. So you're going to go 0.39 divided by, the given was what? 0.48. What does that give you? What's 0.39 divided by 0.48? 0.81. And if you change that to a percent, it's about 81%. They're just rounding them. So your answer is 81%. You don't have to put anything in the results block. I got this off of the computer, and so if you got the answer right, it tells you it's right, or if you got it wrong, it tells you that it's wrong in the results box. All you have to do,
How do you know?
I want you to show your work on each one of these, though. The one that says and in it. The one that's an intersection. Remember an and is an intersection? See? Look, probability A and B. I'll give you a hint. It's always the smaller number is on top. It's really easy. Okay, you guys, this assignment and the extra credit are due next time. You guys can finish this. Seriously, you guys don't get up. Don't get out of your chairs because I want you to finish the assignment before you go. You got 4 minutes. Some of you guys are done already. How many of you are done already with the assignment? Okay, good. It's that easy. You got to finish the assignment before you go. As soon as you're done, finish the assignment, you can go put your calculator away. This and the extra credit are due Monday. No, I don't want it right now. Turn it in on Monday. Okay? Hey, any late work? When did I tell you late work is due by, you guys?
Tuesday.
Tuesday. Any late work is due Tuesday.